Okay, in complex quadratics or hidden quadratics, we have to actually convert any expression or equation that is not in quadratic form, not in the power of 2. Okay,
Okay.
convert any equation to a degree 2. Okay, I'm just going towards the examples because I guess you have already done it in the previous grades, right?
Yeah.
Like well, last year, not the previous grade, last year. Starting with an easy example, like 8x to the power 6 minus 9 is equals to 0. Here you can see that this power of x is 6. This is 3. We cannot solve them. They are polynomials now, right? Eventually, we need to factorize them or convert it into quadratic at least to solve them, right?
Right.
So what we do, we have to see the power of x. Uh, the the major thing here in the complex quadratics, you will see that the first power and the power immediately coming after it, like the first power and the second power are always in the multiples of other, right? If you see
Mm.
6 and 3,
Right.
6 is a multiple of 3. Like 3 times 2 is actually 6. All the powers, the most highest power and the second highest power, always are in a relationship in a sense that they are multiple of each other. Okay, does it make sense?
Yeah.
So
Yeah.
what we can do in that case, yeah, we can we have to always consider the power that is the second highest, right? If I say, let's assume x cubed is equals to u, right? Then x raised to power 6 can be written as x cubed whole to the power of 2, because according to the laws of indices, I can split them up, right? And since x is equals to u, so u squared. And if I use the values back into the equation, it is x, in the place of x, I can write u squared minus 9. X cubed is now u plus 1 is equals to 0. You see now, if I highlight the relevant values, this is this, and this is this. Does it make sense?
Yeah. Can you explain how x to the power 6 becomes x cubed and then that becomes used to the power of
Yeah, why
2?
not? So here, x to the power of m whole to the power of n, according to the rules of indices, can be written as x to the power of m into n. Remember, 6 can be split up
Yeah.
into 3 as 3 into 2, right? So that's why I can write x to the power
Right.
6 as x to the power of 3 whole to the power of 2. That is actually equals
Mm.
to x to the power of 3 into 2. And that is actually 6 again, right? Okay, one other hint. Whenever you are solving complex quadratics, you would realize that the second highest power,
Right.
when you multiply the second highest power with 2, or when you take the second highest power squared, you are actually getting the highest power. So you have to just go and grab the second highest power and make it equals to any variable. When you square it, you will be getting the second highest power. So eventually you are squaring the variable you have assumed it for, right? And hence you are converting it into a quadratic. Making sense or not? Yes, making sense or not? Hello? Oh, hello. Okay, Ali Hadi is disconnected. Okay, all right. So now we have the quadratic. We would just solve it just like a simple quadratic. So the factors of 8, factors of 8 that are adding up to give me negative 9. Hello, Ali Hadi, are you there? Can you hear me, Ali Hadi? You see here, this is 8 and this is 1. A and C are multiplied. So 8 into 1 is 8. The factors of 8 that are going to give you negative 9. Any possibility?
Can we just use the quadratic form?
Yes,
So,
using the quadratic formula, simple. So graph the calculator. U is equals to minus b plus minus b squared minus 4ac square root of 2 into u is equals to what? Let
uh,
me do as well. Have you gotten the answer?
yes, I have. So
What is
U
the
is
answer?
1 or
U
U
is
is
1
1
or
over A.
1 over 1 over 8, right?
Yeah,
So our actual u
right, right.
was actually x cubed, right? We need to always find the actual variable's value.
Yeah,
We need actual roots. So basically, this is x cubed is equals to 1 or x cubed is equals to 1 over 8. So x is equals to 1 or x is equals to 1 over 2, right? That is the final answer. Make sense?
right.
Is that okay?
Yeah,
Okay, should I do one more question?
yeah,
Okay,
yeah, sure.
let's do a question. Let's do a question from uh Surge. 3 root of x. So whenever we have a fraction, what we need to do first? We need to get rid of the fraction. So I am multiplying every term with root of x. Is that clear? Any problem till here?
Yeah.
Is equals to 16 root of x. If I rearrange it, minus 16 root of x plus 5 is equals to 0. Okay, now you see that this and this, their power is double of each other, right? How? Root of x is
Yeah.
basically x to the power 1 over 2. And x is actually x to the power of 1. So 1 over 2 and 1 are double of each other. So you have to substitute the second highest power to any variable. Substitute
Oh,
second highest power to a variable. So that when you square it, you get the highest one because they are double of each other, right? So I can say, let's assume
yeah.
root of x is equal to y. Okay? Then my equation would have become, if root of x is equals to y, and if I take square on both sides, square and square, that is going to give me y square is equal to x, right? Make sense? So my equation is now
Right.
3y squared
Yeah.
minus 16y plus 5 is equals to 0, right? So if I highlight it, this y squared is actually equals to x, and this y is actually, sorry, this y is actually equals to my root of x. Make sense?
Yeah.
Now
Makes sense.
factorize it. Factors of 15 that are giving me minus 16 or addition or subtraction. Do we have any? Quickly.
15 and 1.
Minus 15 and minus 1. Okay? I need minus 16 on addition.
Okay.
When you add them back, this is minus 16,
Mm.
right? So I can say
Right.
that 3y squared minus 15y minus y plus 5 is equals to 0.
Won't it be
3y
minus 15 and 1 then?
minus
No, it's
15
ours.
minus 15 plus 1 is equals to minus 14, isn't it?
Yeah. Yeah.
Okay. So taking 3y common out, it would be y minus 5. From here, I am taking minus 1 common out. Y minus 5 is equals to 0. So 3y minus 1 and y minus 5 is equals to 0. Y is equals to 1 over 3. Y is equals to 5. But my y was actually equals to root of x, right? Making sense? So root of
Right.
x is equals to 1 over 3, or root of x is equals to 5. Taking square on both sides to find the value of x, right? Right?
Right.
1 over 9. 25. So that's the answer.
Yeah.
All good? I'm zooming out. Just go through. If you have any questions, you may ask.
Done.
Done?
Yeah.
Okay. One more question I'm going to do. In today's class, I will be giving you less question to practice during the class because I want to cover the maximum I can. Okay. So please be prepared for your homework. Okay. So the next question is, the recording is going on, right? Can you verify? Yeah. Okay. So the next question is
Yes, miss, the recording.
2x plus 1 is equals to 82 3x minus 27. Okay. First of all, the very first step is to rearrange it. Always first rearrange your quadratic. It should be your very first step. Okay. Rearranging would give me something like 3 to the power of 2x plus 1 minus 82 into 3 to the power of
Oh,
x and 27 is equals to 0. Now, please think, Ali Hadi, which one is my first highest power, like at the highest power in terms of x, and which one is my second highest power, and how can I assume which term I can assume to some other variable?
hmm.
Think we need to apply the
Miss,
laws
if
of
I
indices.
multiply 82 and 3,
I cannot multiply 82 and 3, beta. This term is only in terms of x. This has the power of x. How can they two be multiplied? No. Now
hmm.
my variable term is this and this. Okay? And always the second highest power term is the one that I have to choose to make it equal to some other variable. I told you that the first highest power and the second highest power, they are actually double of each other. But here, how they can be the double of each other? The double of 3x should be, let me do it, like 3x double, sorry, 3x double is square of it in terms of hidden quadratics, and this should be 3 into 2x. But this term is not 3 into 2x, 3 raised to power 2x plus 1 means I have another thingy plus 1 in the power. How can I get rid of it? Because if this is gone, then they are fine. 2x and x are double of each other. I can write 2x as square of 3 to the power of x, right?
Right.
I can split it like this. I can get it like this. They both will be now double of each other. I can assume 3 to the power of x as u, and then this would be u squared. But what should be done with plus 1? Try to think of the laws of indices. Quickly, quickly.
Miss, I'm not sure.
Okay. So basically, I can write this thing as 3 to the power of 2x into 3 to the power of 1. Can I? Up- Remember the laws of indices?
Yeah.
The law of index said that x to the power of m into x to the power of n is equals to x to the power of m plus n. Remember?
Yeah, I do.
So we would be applying the same approach. So this is actually 3 to the power of 2x into 3 to the power of 1 minus 82 into 3 to the power of x plus 27 is equals to 0. Now my these two terms are actually all like double of each other. I can say that which color I used
Mm.
before? Okay. Assuming 3 to the power of x is equals to y, right? And if I take
Right.
square on both sides, 3 to the power of x whole to the power of 2 is equal to y squared, and that is actually equals to 3 to the power of 2x is equals to y squared. This is what we want. Now our equation would be in terms of quadratics, right? So y squared into 3 to the power of 1 minus 82 into y plus 27, and we would rearrange. And these are actually this y squared is actually equal to 3 to the power of 2x, and this y is actually equal to 2 to the power of x. Make sense?
Yeah, makes sense.
Okay, now I can write it at 3 to the power of 3 into y squared minus 82y plus 27 is equal to 0. Can I simplify this?
Yeah.
How? Is 82 a multiple of 3? Can I divide the whole equation by 3 or not?
No,
Quickly, Ali
because
Hadi.
82 is
No.
indivisible.
Yeah. 27, sorry. 27 into 3 is equals to 27 into 3 is equal to 81. Factors of 81 that should be added to give me minus 82.
This again, can we just like it's easier for me if I just do the quadratic form.
Sure. Y equals to, help me to get it. Minus 82 plus minus 82 whole square minus 4 into 3 into 27. Because this step I have to show, right? After that, I can do directly onto the calculator.
Mm.
Uh, you can get the value meanwhile. Mm, 82. So y is equals to 0.33 or y is equals to 27. I did quicker than you. Alihadi, are you not doing it on the calculator?
I was taking notes.
No, don't take notes. I will send you the PDF. Stop. Just focus. Why I'm
Oh,
doing it here, Bete?
okay.
What's the reason? I want to save your time. That is why I'm doing each and everything by myself. You just focus on the class. Spend your every minute in just focusing and understanding the concept. Stop writing. Okay. Just focus,
Okay.
understand, and do the working on the calculator for me. Save my time this way. So that is 3 raised to power. Oh, I need to change color. 3 raised to power x is equals to 0.33, or 3 raised to power x is equals to 27, right?
Right.
Okay. Now, 3 raised to power x, need to find the value of x basically. This is actually 1 upon 3. Or 3 raised to power x is equals to 27. So I can write this as 3 raised to power minus 1. So x is equals to minus 1. Or this is 3 to the power of 3. Or x equals to 3. This is also a rule of index. If the bases are equal, the powers are same. All right? Make sense?
Okay.
Okay, I'm going to give you a question right now to do. Now do this question. Root of x into root of x plus 1 is equals to 6. You need to first expand and rearrange it, and then assume it.
Okay.